So we're just waiting for more attendees to come in. So we are going to give it a minute or so. You can see the number of attendees is rising, which is quite exciting. Let's just wait a little more for everybody to be in the room. Whilst you are all joining, I look at the stats this morning, and today we have people attending from different countries. So we have people from the UK, we have people from Spain, from Japan, from Ireland, from Kenya, from Ghana, and from Australia so far. So thank you very much for those joining different time zones. I appreciate it. So, right. We have a fair of people in the room, so I'm going to slowly introduce the webinar. So welcome everybody to today's webinar, Why Build an Energy Efficient Home. My name is Sonia Martin. I am the CEO at Bayfield Training, and I'm delighted to have a key professional on the subject presenting for us today. His name is John Wolfendale, Director of Ecovida Homes. And John has a background in energy efficient design and build, architecture and construction, commercial and residential property investment analysis and valuation. And he's a British qualified chartered surveyor living in the south of Spain. Ecovida Home has been trusted by many other professionals in the property industry to design and build their private villas. And they are regulated by the RICS in London. So John, thank you very much for being here with us today.
Thank you, Sonia.
Great. So, but before I hand this over to John, and for those who are new to these webinars, I would like to mention a couple of things about Bayfield and about Zoom. So regarding our property webinars, we are delivering free webinars in a weekly basis. They are all related to the real estate industry and presented by key professionals. You can find all of our webinars on our website or on our LinkedIn page. And by attending 5 of these webinars, you are entitled to get 20% discount in our public courses worldwide. So regarding our courses, we are a real estate executive education company based in Cambridge in the UK. And we just have launched our courses in 2 formats. Online using Zoom. We have been doing this for the last months since COVID started, and it's now a permanent solution that we offer to all of our clients. We also have the classroom-based courses in London. This is a format that we have been using for the last 20 years. We stopped due to COVID, and we are now back in London, and we're just waiting for the government tomorrow to mention further arrangements with this, but we are still open on that. And we also have launched a new service. It is called Virtual Real Estate Model Coaching. And basically, you can book 2 hours with our experts and go through your model. We help you to identify the areas of development and provide guidelines to improve the robustness of your models. And if this is of interest, we offer a 10 minutes free phone call with our expert before you go ahead with the booking. And if you would like to know more about Bayfield, just send us an email at info@bayfieldtraining.com. And now going back to the webinar, the presentation will last 20 minutes and it will be followed by 10 minutes of questions and answers. So if you got any questions, you can use the Q&A icon for the purpose. To find this icon, just move your mouse to the bottom of your screen and you will find the icon there. You can write your questions throughout the presentation and we will try to address them at the end. So, and if your question has already been asked, you can like the question so it goes to the top of the page. We also have a chat option and you can use for technical problems if you have any, and I will try to solve them. And that's it from me, and I will hand this over to John now. Thank you very much for listening. Thank you.
Thank you for that, Sonia. So before I start, there's a disease going around, it's viral, it's called expertitis, okay? And it kills authenticity. I don't know whether I've got it or not, but let me just say that, you know, I'm happy to share with everyone what I know. I've been studying the energy efficiency houses and their construction for about 10 years now, and it's what we do. So everything that we build in Spain is energy efficient. And I'm happy to share what I know, both obviously on this webinar, and if anyone wants to contact me afterwards, I'm happy to share what I know with them. So the title of the webinar, an energy efficient home, or why build an energy efficient home? And there are 4 reasons we're going to run through very quickly. They're more comfortable. They're less expensive, both to build and to run. They're worth more. And an energy efficient home helps save the planet. So let's take each one of those in turn. An energy efficient house is more comfortable. Okay, so comfort is a subjective thing. It's a combination of temperature, humidity, and air movement. So what I want to do is look at that, and at the same time try to just talk a bit about the passive house standards, because this is to kind of to kill 2 birds with 1 stone. What we can do is we can look at the passive house principles and look at each one in turn and say why that makes, if you apply that principle, why it's going to make your home more comfortable. Okay, so by way of background, passive house, this is a German institution, and they have developed a methodology and quantitative standards for achieving energy efficiency. And they're basically, they've sort of set the standards across the industry for how to do it. And you know, I would say they're probably the top. If you got a passive house certificate, that's probably the best certificate you can get. Passive in this sense kind of means without doing anything. Okay, so it's like the opposite of active. So a passive principle would be something like insulation, and an active principle would be something like, you know, electrical air conditioning, or some electrical heating or something like that. And these passive houses came out of Northern Europe, really, where, you know, it might be minus 20 degrees centigrade outside, and you need no heating on the side of the house. Okay, so it's just passive. You're using your body heat, or maybe the heat from cooking, to heat the house. And they provide certificates. All right, so if you qualify, you get your passive house certificate, which is a valuable thing to those people who want it. And they test it. Okay, so one of the best, most interesting, fun tests, if you like, is the blow door test. They close all the doors and the windows of the house, stick an enormous blower on the front door, turn it on, and then measure the air tightness of the house. And if it doesn't pass, then you have to go around, you know, trying to find the leaks and everything and fix them up to get the blow test again in order to get your passive house certificate. They provide training programs for architects and other professionals. One of the things here about the passive house is that as part of the design process, when you do one, you have to do what they call a PHPP test. And that's the passive house planning package. And what it's basically an enormous spreadsheet. I think there are 16 different big pages on this spreadsheet, all interrelated, and you detail on that spreadsheet every aspect of the specification. And, you know, the result will be, you know, will I get the certificate or not if I build according to this specification, which allows you to tweak the specification so you get that right before you start to build. Now, an important point here that I can't emphasize enough, really, is that you can build an energy efficient house, and you can even build to passive house standards and not bother with the certificate. Okay, and in fact, that's really what we do. I mean, with one exception this year, we tend to do that. So we've learned from the passive house principles, we apply them, but most of our clients don't bother with the certificate. You know, we've got enough bureaucracy in Spain as it is without adding another layer, and there are costs associated with that. But we do have one client that wants to get the certificate, or actually they're not quite sure yet, but they do want to build to the passive house standards. Okay, and there are other reasons why you might not want to actually bother with the certificate, which we might go into later, because obviously the climate in Spain is a little bit different. People have a different set of priorities. You know, they don't necessarily want to live in an airtight box in Spain. Quite the opposite. You might want to open all the windows and live mainly outside. But if we look now at the slide, just going to the slide, and we look at, on the left-hand column, I've just outlined really the sort of 4 key principles of a passive house design, and looking at those one by one to just say why that makes why it makes it more comfortable. Super insulation, you know, obviously it's going to keep you cool in the summer. It's going to, if you've got the house cool inside, then it's going to keep the cool inside in the same way that it keeps the heat in the winter. And of course, it keeps the heat out too, just in the same way that in the winter it keeps the cold out. They're more likely to be quieter. Okay, I don't know if any of you are familiar with Spain, but acoustic insulation is not often a priority in Spanish builds. You may have been in a hotel where you can hear everything that's going on next door. So thermal insulation tends to provide acoustic information at the same time. So that's a comfort point. And then quite often with energy efficient homes, well, underfloor heating is a very energy efficient way of transmitting the heat, and it's just more comfortable. Okay, if you just heat the air, you get a different feeling. Whereas if all the walls and the floors and the furniture, if they're all at the right or the same temperature, you get a kind of radiant heating, which is just a much more comfortable feeling. The second passive house principle I put on the slide, air tightness. Well, obviously there are going to be no drafts. And the third one, the mechanical ventilation and heat exchanger. I mean, we're putting in these into a lot of our homes now, designing them in, and they're not passive homes, what we're doing mainly, but I really think this is a big improvement in how to do this. What happens is that you take the wet and dirty air out of the kitchen and the bathrooms, and you exchange it with fresh air from the outside. But as you do that, it exchanges the heat. So it's going to keep the air, so you're going to keep the air cool if you've got it cool in the summer, or keep it warm if you've got it warm in the winter. And that those heat exchangers are very efficient. They can work to sort of 98–99% efficiency. So you've got clean, fresh air in your bedrooms and your living spaces, and you're expelling the dirty air, so it's much healthier. There's less allergens and mold and mites and pollutions in the air. It's very healthy. I think it really makes a difference to the quality of life. And then finally, we've got here the fourth point: the passive house designs are very big on solar orientation, as are we. Whenever we design a house, particularly in Spain, where we've got a kind of cooling problem in the summer. The Andalusian sun in the summer, in July and August, is really very, very powerful. So we are thinking a lot about controlling that, about shading, retractable awnings, and of course, potentially a deciduous vegetation, which is a nice way to do it, because the leaves fall off in the autumn, so you get the solar gains in the winter, which is what you want. And they grow back in the spring, which gives you shade in the summer. But we're always thinking about the solar orientation in what we do, energy efficient homes, as indeed are the passive house. And there's lots of other things, of course, that go into the design, such as, you know, the natural light, the views, and, you know, how you're going to use the house. Oh, I remember a rotating house. I did a blog post on this years and years ago as a kind of joke, thinking that, you know, if we had a rotating house, then you could have it wherever you wanted, according to the season and the time of day. And there is one. I saw one the other day. It's down there in Marbella. I don't know how they do the services, the plumbing and the electrics. I expect there's a kind of a part in the middle of the house which is static, and the house revolves around that, if you like. But I don't know. I've only seen it from the outside. Okay, Sonia, if you're there, next slide. Should we look at the next slide? We've got here an energy efficient house is less expensive to build. Okay, and I put up here a couple of cash flows. That picture you can see, that's one that we finished towards the end of 2018, 2019. So we're looking at a real case study here. And I should say that okay, that is, if there were such a thing, that would be an active house. Okay, it's carbon zero because it produces all the electricity that it uses, but it's absolutely stuffed full of energy consuming mod cons. I think they've got 2 electric ovens, you know, dishwashers, tumble dryers, washing machines, underfloor heating, and a heated pool, okay? And a contraflow system in the pool, so they can take exercise by swimming against the thing. So, but it's carbon zero because it generates all its electricity. And you can see in that second picture an aerial photograph of the PV panels. And I suppose just before we turn to the cash flows briefly, I think it's worth pointing out here that really the cost of all this, the cost of your renewable energy system, extra insulation, the mechanical heat, ventilation system and so on, that's really quite small by comparison to the other kinds of decisions that you might make. All right, so in Spain in particular, most people want a view. If you want a view, you're building on a slope. If you're building on a slope, you've got to have a retaining wall, and that's expensive. You know, some plots which are advertised are really effectively cliffs. So you're going to have to dig out and build a platform out, and that's expensive. I mean, that's going to be, you know, something like as extreme as that could easily be over 100,000, maybe 200,000 euros just for that part. And you're looking at a lift and this sort of thing. So these costs of, in a more conventional situation, these costs of doing this is not a big item in your overall cost of the build. And on this particular case, just to point out, with this one we did in Las Chapas in Marbella, is this is quite a big PV system. All right, so more typically with our clients we'd do something a little bit smaller than that. The house is on grid, okay, so it can be supplemented by grid electricity. And the other thing I thought I'd just say is that these days, this is something which has evolved really since we did that house, is that at the moment we do not recommend solar hot water, because if you have solar hot water, you get lots of hot water in the summer when you don't want it. And what you need in the summer is electricity to power your air conditioning. Okay, so all the renewable energy system is photovoltaic panels, and then you've got electricity to provide your hot water, the kitchen and bathroom in the winter, and lots of electricity in the summer to provide air conditioning. Also point out that the panels are not perfectly angled. They're angled to the west and the east, because actually they don't need to be perfectly angled to be effective. And the other interesting thing about this system is that the heat which is generated by the air conditioning systems, you know, when you touch the back of an air conditioning system, it's hot at the back. Well, that heat is fed back into the hot water system. Looking at the financial analysis briefly, you can see that we've got the present value of all the costs without the system is 115,000, and the present value of all the costs over a 20-year period with the system is 94,000. So that sort of supports my claim that an energy efficient home is less expensive to build just on the basis of the renewable energy system. But I am fully aware that you can prove whatever you want with a spreadsheet. So, you know, there are some qualifications to this. We've got, if you look at year one, on the right-hand side, this is the actual cost, the 64,000. That includes the heat pump, the battery and the inverters and the whole system, the installation and VAT. I've got a 3% discount rate over the 20-year period, but of course, actually it works. It proves its point at any discount rate. I'm assuming the electricity costs rise by 20% every 5 years, which in Spain is certainly historically a realistic assumption, but of course that does vary widely across countries. And then I put in at the end of the 20-year period, I put in the cost of renewing and maintaining the system at 1/3 of the initial installment costs. Okay, so key points to take away from this part of the presentation is really you have to do an NPV analysis to establish the facts. Electricity and cost inflation has been a reality in the past and is likely, or is likely to continue. Electricity cost inflation. The costs of all this is quite small by comparison to other costs of your build. And importantly, to have a carbon zero building, your lifestyle doesn't have to suffer. You can have all those electric ovens and microwaves and everything you want, providing you're generating. in a green way your electricity. Okay, so the next slide, please. Sonia, an energy efficient home is worth more. Okay, again, a bold claim, but really, you know, there's lots of studies have established this. If you put it into Google, you'll see them all. Just 3 here that I've got written down in front of me to tell you about. There's one here from 2019. It's an American study. People will pay $8,728 more in order to save $1,000 on their utility bills. Okay, there's another one here. This was actually dated 2016, published in The Guardian. 89% of people would pay more for an energy efficient home. And thirdly, there's one here which is from 2012, which establishes that energy efficient homes are 9% more valuable than non-energy efficient homes. Okay, but there's lots of this done. I just, you know, what interests me is why. Okay, why will people pay more for an energy efficient home? Because once you've established that, it's just supply and demand. And, you know, I've listed them here. They cost less to run. Energy prices are rising, so that factor is going to increase. They're more comfortable. And people want to lower their carbon footprint, and most people do. Most people accept that the you know, global warming is a reality and want to lower their carbon footprint. Tax regimes increasingly are likely to favor the energy efficient homes, and importantly, you can measure it. Okay, so you can measure. These are measurements. I put down 4 of them here. That once you can measure something, then you're much more likely to believe it and trust it, and then believe that it's and pay for it. Okay, so these, just run through these kind of green building accreditation systems. We've got energy certificates, which are mandatory now in Europe for letting or advertising of property. They last, each one lasts 10 years. We've got BREEAM, which is a British methodology, but adopted worldwide. LEED, which is an American one, again adopted worldwide. And these ratings mean that buildings can easily be compared by their running costs, how comfortable and healthy they are to live in, and their environmental impact. So that's how they're measured, generally speaking. And NZEBs are mandatory in Europe for all new buildings from 2021. Now, an NZEB, that can be a net zero building or a nearly zero building, and which one of those? I think it's a slight political issue, to be honest with you, because what it does is it allows each country in the European Union to interpret that rule in a different way, which means they can take longer to comply with the legislation. Okay, next slide, Sonia. How are we doing for time? We're okay. So an energy efficient home helps save the planet. You know, this is not a big big news, really, but I think what it's worth pointing out is, you know, how much effect this really can have. We know that burning fossil fuels is the key thing that we've got to stop doing to stop global warming. But if we look at these figures that I put down here at the bottom on the left-hand side, I mean, look, these are loose figures, okay? You know, it depends how you measure it and which country you're looking at and so on. But essentially, 60% of electricity at the moment is generated in general terms by burning fossil fuels. In Spain, they're quite good at wind power in Spain, and on a windy day, you know, can get up to 85 or probably more % of the nation's electricity, which is generated by wind power. But in more general terms, you know, it's got to be a windy day and so on. More general terms, 60% of electricity is generated by burning fossil fuels, and 30% of that is used domestically. Well, an energy efficient building, if you look at that Las Chapas case study, I mean, you know, it's probably reducing the electricity bill by you know, 80% or something like that. So even with a retrofit and so on, if you can reduce your domestic electricity consumption, you really can have an effect on this. You could have, you know, we could potentially reduce that 30% down by, you know, 60 or 80%, and that would have a big effect. And you know, we're not going to stop flying, probably, any of us, none of us are probably going to stop flying. We might reduce it a bit once we're allowed to fly again. But this is something that I think, you know, is within everybody's reach. That's why I put on the right hand side, an energy efficient home has a direct effect on reducing global warming. Finally, we promised that we would look at future trends in energy efficient homes. I'm going to express a kind of personal prediction. It's anybody's guess what might happen, but I think the way we're leading is into lots of photovoltaic production of electricity. So I think, you know, you've got the Tesla roof tiles that lock into each other, and they're really, each one is a photovoltaic panel. Well, I think we're going to see that on building facades and even on windows, which will of course reduce that you'll get a tinted window effect, a sort of shaded effect, but you'll be gathering photovoltaic electricity from all the outside surfaces of your buildings, and every home will have a battery and an electric car that will work in tandem. So according to, you know, you'll still be on grid, but where you might be charging your car or your domestic battery, augmenting those charges from the grid when the tariffs are low, and then you might be boiling your kettle from your car battery, depending upon the time of day and how which of your batteries are charged or not. So that's a little prediction from me on, or at least about the future trends and where we're going with energy efficient homes, where we've got communities, you know, rather than individual houses. Then I think we might have a local renewable energy source, because of course you lose 20–30% of the power just transporting it from the coal-fired power station to the domestic user. So it's much more efficient to produce and consume the energy locally. Okay, Sonia, that's the end of my presentation. If you want to open it up to questions or let me know if there are any questions, then we can go ahead with the questions.
Great. So thank you very much, John. We are now moving indeed into the Q&A session. So please send us your questions. Use the Q&A icon for the purpose. We actually have a question on the chat, which is completely fine. So I will just read this question to you, John. What is the price per square footage, including construction cost and the off-grid system?
That's the first question everyone asks me. I've got protected behind a password on our website in order to protect our clients' privacy. I have publicized I haven't publicized it. I've protected behind a password. I've got all that information. Okay, so you can see not only on that project, but on 3 or 4 other projects, all the costs. But it is behind a password to protect our clients' privacy. If you want to get in touch with me, and you know, providing we can just check it all out, then I'm happy to let you see that. We use for our clients now, I recommend that you should be using about 1,500 to 1,600 euros per square meter for a turnkey cost. And that's just for the gross external area of the villa itself. So that excludes taxes, professional fees, but importantly, it excludes, the swimming pool, the outside terraces, the front gate, the driveway, the garden, all those sort of things. And that can all mount up to a lot. But again, I've got a back of the envelope cost guidelines, which I'm happy to share with anyone who wants to send me an email. And I can ping that over to you an email, which allows you to sort of do your own back of the envelope costs to decide whether, you can calculate back from that and the size of plot you need, or the size of house you can build, or work out whether it's feasible or not. It's the first question everyone asks me, so I'm ready for it.
Great, John. I mean, it's nice that we have questions. I got another question from Mark. He's saying, which materials are used for external walling? Is thermal cork insulation used, or a typical through color render such as Tuco or K-rend? I'm sorry, I don't know this terminology. Did you understand
I
the
can't
question?
read it. What we use, I haven't fully understood the question. If you email me, I'll answer it more precisely. We use as standard, and we do what our clients ask us to do. So we've got an architect client, for example, from Ireland, and he specified 20. This is interesting because he's an architect himself, right? And he specified 20 centimeters of insulation in his build. It's his villa that we're designing and building for him. As a standard, we'll use 10. So it'll be 5 centimeters of rock wool and 5 centimeters of polystyrene. They work well together, and a cavity. Don't forget the climate in Spain is a little milder. The architect says 20 because he understands the importance of this, all right? But the building regulations in Spain specify a minimum of 3. So that gives you an indication of, you know, I think the minimum standards that you're allowed to build in Spain are just too low, really. But it's a mild climate in Spain. We don't need masses of information of insulation.
John, is it thermal cork insulation that you use?
We don't, but we would do if our client requested it. And you know, it's one of the things we do. We'd look into it and look at the pros and cons of the different. So we need to understand why they were wanted to do that, and then understanding why they might want to do that. Look at the pros and cons and the costs, and you know, potentially even the carbon footprint associated with that material. Locally produced cork, because there's embodied carbon in every material that you stick into a house. So you know, if you're importing polystyrene, potentially it might be energy efficient, but it might be less sustainable, depending upon how you use that word, because of the embodied carbon in the material.
Right. Okay. So hopefully that will answer the question. So moving on to more into the other kind of weather, like the Nordic countries weather, I would like to know whether you know, these passive houses, are they built in the same manner than the ones you build in the south of Spain? If not, which are the key difference?
Well, the principles are all the same. So when you do this PHPP study, you have to say where, in other words, which climatic band your building is located, and that will change all the other how all the other values are calculated. Okay, so we've got a cooling problem in Spain mainly in the summer, but we also have a mild heating problem in the winter. Whereas in Northern Europe, you've mainly got a heating problem in the winter. Okay, so it's the window sizes and the window orientation are going to be different in Northern Europe, and the amount of insulation that you need are going to be different. But I suppose the spreadsheet principles or the principles of the passive house are the same, but of course the climate where you are gives you a different problem and will require, in order for you to meet the passive house standards, different specification and different solution.
Thank you for that. So I got another question for you. Can you give us some tips of how we can turn our existing home to a passive home?
Well, yeah, I mean, certainly I'm not sure if I would I'm not sure whether even if you can actually get a passive house certificate on a retrofit. You probably could, but you don't hear much about that. So I kind of don't know whether that's a thing or not, but certainly you can take your existing home and make it energy efficient. And I would encourage everyone to do that. And it's you know, the principles are fairly straightforward. You want to, you probably want to, it depends on what you've got, but you might well want to improve your window specifications to replace all the windows, replace all the doors, and then in Spain it's called sate, but basically if you insulate the outside of the building, then you don't have thermal bridges. Okay, and I wanted to mention that when we talked about super insulation earlier in terms of the passive house. A thermal bridge is a real problem, and it's a problem in design. But what you want to do is avoid them, and a thermal bridge is like a a superconductivity between 2 point, you know, all your insulation and air tightness and so on. If you've got a thermal bridge, it really counts for nothing, because because it's one weak point in the design that all the heat escapes through that point. That's why for a retrofit, if you insulate the outside of the building, you put your insulator on the outside rather on the inside, because on the inside you know you're going to have bits that you can't insulate. Whereas if you insulate the outside and the roof, then you can do it without thermal bridges. That would be a key thing. Replace the doors and windows, and then of course you might want to. I would definitely recommend a mechanical ventilation system and heat exchanger, because I think it's healthy too. So those would be my key points in terms of a retrofit.
Right.
Go on.
Thank you very much, John. Please send us a question if you have any. In the meantime, I got my last question for you, John, and is, do you live in a passive house?
I don't, but I do live in an energy efficient house, and I'm not sure if I'd want to, you know, personally. I mean, it's a growing movement, and a lot of people are passionate about it, you know, get kind of, you know, really into it. I mean, the PHPP, if you're that kind of person, if you like details and things, it's you know, wonderful for those people who love that kind of thing. Personally, you know, the climate in Spain is so, you know, one of the reasons why we're here, to be able to live. I'm a kind of open all the windows guy, I'm afraid. And the most valuable point of your property, in my opinion, isn't inside, okay? It's that point outside when you're in the shade and you're looking across the view or looking across the water and maybe your swimming pool, because that's the point where you have your cold beer, or you read the newspaper while you're having your coffee. You know, it's that point which is generally speaking going to be outside, shaded, but outside in front of the view, near the kitchen or at least the fridge. And so, you know, a passive house, to get the passive house certificate, you've got to have this sort of airtight box, and it's not for me personally, but obviously it is for a lot of people.
Great. Thank you very much, John. We don't have more questions from the attendees, and we are running out of time now. So we will be sending these slides to all of you, and I will put in the post webinar email John details if you want to talk to him. And yeah, I would like to thank you, John. It was great presentation, great Q&A, and thank you to all of our attendees. And yeah, I hope you all enjoy it. Have a great day and stay safe. Thank you very much.
Okay. Thank you, Sonia.
Thank you very much. Bye-bye.